Thank you. Thank you. Thank you, thank you, thank you. Make sure you, check the attendance sheet when it comes to you. Do I have everybody's? Thank you. All right. So I will work out a solution to that and post it for you guys sometime soon. Now, so let me begin with a word of prayer. Ahem. Ahem. I will pray. Dear Father, we thank you for this day. I thank you for these students. Just ask you guide our steps today and just help us to understand a little bit more about your creation together, Lord. In your name I pray, Lord Jesus. Amen. Okay, so first things first, your questions, you had questions about the problem, what was it, 42? 43? Is it involving square roots and stuff?
Yeah.
Okay, yeah, we're about to cover those.
Okay.
Yeah, we'll cover things like that. And 41. So 41 we covered last time. So for 41, what you want to do? So for problem 41, I'll just say this. What is this? Weirded me out. For problem 41, here's a hint. Rewrite as, fraction. Is it less than or equal to? Okay, so you can rewrite that. You can subtract things from one side to the other and convert it into a fraction less than or equal to 0 or greater than or equal to 0 problem. Then what you want to do is simplify the fraction, find the critical numbers, go from there. That's the way to do that problem. Problem 42 involves laws of exponents. All right, so let's talk about laws of exponents. Laws of exponents. So, what are you guys doing? Oh, I see. I got you. So here it is. X to the a times y to the b is x to the a plus b. So this is one law of exponents. If you, oh man, what have I just done? Let's try that again. X to the a times x to the b is x to the a plus b. All right? This is one law of exponents. Another law of exponents is if we have x to the s raised to the t power, we have x to the st. So if you multiply exponents in that sense. How about division? How does that go? What if we have x to the a over x to the b? Yeah, x to the a minus b is how we would simplify that, right? All right, other notation. The nth root of x is by definition x to the 1 over n. I mean, well, I don't know if that's a definition or if it's notation. What does this mean, though? What does it mean to say you've got x to the 1 over n? What equation does this satisfy? If I tell you y is equal to the nth root of x, what's that mean? What's this interchangeable with? This is interchangeable with y to the n is equal to x, right? So the natural enemy of the nth root is the nth power function. If you have the nth root and I raise it to the nth power, they undo each other, right? Now, I've got to be careful here. This is assuming x is greater than or equal to 0. All right, so if x is less than 0, it's a little bit slipperier in the following sense. If, well, how to say this? Well, let me just talk about the tricky part. Here's the tricky part. Okay, so this is for x a real number. So it could be positive or negative, all right? Could be positive or negative. In this case, here's the thing. The square root of x squared, right? What is the square root of x squared? X, you say, and I say sometimes, but generally it's absolute value of x, actually. So by definition, the square root, so here, it's definition. Y equals the square root of x if y is greater than or equal to 0 and y squared is equal to x. So it's by definition, by the very definition, the square root has to be non-negative. So when you take the square root of a square, you have to have something that's either 0 or positive, which means I have to put the absolute value there. Just let me show you how it works. So if I take the square root of 5 squared, well then we'd agree. Square root of 25 is what? 5, great. But the square root of minus 5 quantity squared is equal to the square root of 25, which is also equal to 5, right? But 5 is the absolute value of minus 5. So in all cases, the square root of x squared is equal to the absolute value of x. We've been using this whenever we do the plus or minus property. When we take the square root of both sides of an equation to get rid of a square, we put in plus minus because of this, right? So this has already been with us in certain problems. This continues to be the case. So like, if you have, the 2nth root of x to the 2n, it's equal to the absolute value of x. So because the even root of a number is defined to be the positive or the non-negative root, all right? So like the 4th root, the 6th root, all these things, they're necessarily positive. The interesting thing is, for odd roots, this doesn't happen. So if you have like an odd root, x to the 2n plus 1, x to the 2n plus 1, in this case, you can just write x. So there's a big difference between, say, a cube root, a 5th root, versus a square root or a 4th root. So for example, if I have the cube root of x cubed, it really is just equal to x again. For example, just to make it a little bit more concrete, if I have the cube root of, say, minus 2 cubed, how does that go? That's the cube root of minus 8, yeah? And that is equal to minus 2. Why is it equal to minus 2? Because minus 2 times minus 2 times minus 2 is equal to minus 8. So cube root, we can take the cube root of any number. Cube root makes sense for positive numbers and negative numbers, but the square root is different. We can't take the square root of a negative number unless we're willing to do what? Use complex numbers, right? So if we take the square root of a negative number, we get complex numbers and all that. So that's the tricky part. Now, to avoid all this, if I just assume that x and y are positive, so here's the deal. If x is positive, though, what do you get? If x is positive, then the square root of x squared is equal to what? X, right? In fact, the nth root of x to the n is just equal to x. In the other notation, this looks like this. X to the n to the 1 over n is equal to x to the n times 1 over n, also known as n over n, which is equal to x to the 1, which is equal to x. So these laws of exponents that I wrote for you guys at the start, there's terms and conditions back over here, right? What are the terms and conditions for me to write these without qualification? I'm presupposing something about x here. What? X is positive, right? So these assume x is positive. If we're dealing with a fractional power of a negative number, it's annoying. We got to think about things. So, all right. So I've told you about the tricky part. Now let me try to focus more on the part which is not tricky. Here's an example which is like your homework, but different. So this is the problem I'm about to do is kind of in the neighborhood of problem 42 in your homework. Let's see here. So this, I guess, is example 1. So suppose you've got x and y are positive, all right? And let's suppose that we've got x squared times the square root of xy divided by the cube root of xy squared. And that's equal to x to the a times y to the b, and then I say find a and b. How do you do this problem? Let me kind of walk you through it. The idea here is to apply the laws of exponents, all right? Apply the laws of exponents to simplify the expression on the left-hand side till it looks like the expression on the right-hand side. And once we do that, we can read from it what a and b are. So, you know, it might be helpful if I had written also another law of exponents over here. One of the other here's what I forgot to tell you guys. If you have x times y raised to the, let's say, whatever, p power, p, that's equal to x to the p times y to the p. If you look at this in terms of the fractional notation, so like this also means that the nth root of x times y will be equal to the nth root of x times the nth root of y. This is also true, all right? Another thing is if you have the nth root of, say, x over y, that is equal to the nth root of x divided by the nth root of y. These are things that, you know, are nice to know about when you're working a problem like example 1. All right, so I'm gonna put a vertical equals here if you guys will forgive me for it. Actually, no, I'm gonna put the x to the I'm gonna put the x and the y over here, and I'm gonna work over there. That'll be better for me. So that way I'll get out of the way. What do you guys think I should do? Well, here's what I would say don't do. Don't do everything all at once, right? Pick it, like work on the numerator and work on the denominator. Finish those both separately, and then try to put it together. Yeah?
I was going to say, like, first, like, give the x, y back.
Uh-huh. So square root of x, square root of y, like that?
Oh, I was talking about the denominator.
Oh, sure. Cube root, but it's cube root, it's not square root. They don't cancel. So thank you for that question. That's a very helpful question. They do not cancel because they're not the same thing. So this is a square root versus, see that 3? That makes, that's a cube root. So like if I had a cube root, if I had cube root of xy upstairs, then I could have like canceled somehow.
Like I was just talking about hypothetically in the box, the x, y squared.
Ah, yeah. So I can do that, right? I can break the square root of a product into the product of the square roots. The cube root of a product is the product of the cube roots. And then what? I can simplify laws of exponents here, right? Like, what do we got?
You do x squared times square root of x to get x. So it would be x squared.
Mm-hmm.
Or, yeah, x squared times x, or squared to get 1.
So I think this is what you're saying, but this is the step before what you're saying. You're saying to do it and write it down. I'm saying I'm going to put this in between step. I'm going to say, oh, well, these are fractional 1/2 power, right? That's the 1/2 power. That's the 1/2 power. This is the 1/3 power. Y cubed, the cube root of y squared is y to the 2/3, right? Like y to the y squared to the 1/3 power is what? It is y to the 2/3 power, okay? Now, how do you simplify this? We add exponents, right? So I've got x to the 2 plus 1/2, which is x to the, what, 5/2? And, okay, so I did that. Listen, I probably could have, oh, wait a minute, how's that go? Oh, wait a minute. Come on. Is that right? That is a y, right? So, sorry about that. I'll fix it. I was like, wait a minute, that would give you an x. Wait a minute, what happened to the y? Oh, duh. Yeah, okay, so that. So I didn't do much in this step right here. And then here, let me just go to the end. So we have x to the what? X to the 5/2 minus 1/3, y to the 1/2 minus 2/3. So that's x to the what and y to the what? You're like fractions. Ugh. All right, so let's work it out here. 5/2 minus 1/3 is what? You got yourself a 13/6 on the x power. And 1/2 minus 2/3 is, what is that? You are correct, minus 1/6. All right, so what is the answer? What is A and what is B then, now that we've done all this work? 13. Exactly, so you just read from it. So therefore, A equals to 13/6, and my B is apparently minus 1/6. All right? So if you can work one of these problems carefully and reliably, that pretty much shows me that you understand the laws of exponents at a pretty good level. These are challenging problems. When I ask Calculus 1 students this at the start of Calculus 1, people who've already had the course after this course, right, pre-calculus, there's usually about 50% of the students who can't do this problem because they haven't completely understood the law of exponents yet. And or the format of the question just confuses them, but it's not especially important. So does that should help with 42, right? Okay. Okay, so let's move on. I'll talk about the new stuff. So today I'm talking about, well, I've already been talking about rules for radicals, yeah? And so I showed you the rules for radicals, right? But now I want to look at how to solve equations, mostly involving square roots. I suppose I could, let me just jump to the, here, this one's kind of like problem number, we're in section 1.6 right now, guys. So this one here, like number 80, this is example, what, 2? So this is a relatively easy problem. These are like later in the homework. Well, here's one. X to the 3/2 equals 125. This is number, this is number 75, section 1.6, number 75. So let me do a few of these really. This is the weird thing. Usually in these sections, the problems at the end are the really hard ones. And the problems at the start are the not so hard ones, right? This is turned over. Problems 75 through 86, I would argue, are pretty easy. Problems 40 through 74 are more difficult. So I'm going to start with the easy ones. All right? How do you solve this? How do you isolate x here? I'll do this one. What you want to do is you want to take both sides and raise it to the reciprocal power, which would be 2/3. So you can take both sides of an equation and raise them to a power. This is something we can do. What is something to the 3/2 raised to the 2/3 power? See, that's just x again, right? Because the law of exponents, we multiply the powers. 2/3 times 3/2 is just 1. So x to the 1 equals to this. Now that is also, you could also write that as the cube root of 125 squared. Right? Because this is to the, yes? What's the question?
Well, I think you know the answer.
Oh, what's the answer? Yeah.
So cube root 125, you get 5.
Uh-huh.
Squared is 25.
Yeah, you're right. Yeah, 25. Thank you. So that's 5 squared, which is 25. Very good. Because Beth Ann happens to know that 5 times 5 times 5 is 125. Right, yeah. Now, of course, you have a calculator, right? And you can just as well, in your calculator, do this. 125, you hit your caret button, and what do you put into it? You know, 2/3. You can calculate 125 to the 2/3 power in your calculator directly, right? You don't have to do it by hand if you don't want to. That is a squeeze. That is a sneeze of note. Let's see here. So how about this one? Example 3. What if you were up against x minus 3 raised to the 2/5 power equals to 4? Could you solve this one? What should we do here? You say raise both sides to the what? Yeah, to the 5/2. 4 to the 5/2. So we get x minus 3 is equal to, and 4 to the 5/2 we can rewrite as the square root of 4 to the 5th power, which, what is that, Beth Ann? You tell me.
32.
32, yeah. That's 2 to the 5th, which is also known as 32. So the answer is 32 plus 3, which is 35. Yeah, 35. So these aren't bad. Actually, I think these are easier than the one like problem 2 on your, problem 3? 4, yeah, problem 4 on the quiz. The one that had the cross multiplication, it was kind of ugly. Yeah.
Why did you raise everything to 5/2? Are you just doing the reciprocal?
Yeah, exactly. Just it's the reciprocal power of whatever you're up against. That's the natural.
Get rid of the x.
Yeah, so like generically speaking, this is the pattern. If I have x to the s and I want to get rid of it, I just raise it to the 1 over s. And that gives me x to the s over s, also known as x to the 1, which is x, right? So like that's the trick for these problems. All right, so these problems are not bad. Let us talk about the ones which are more challenging. So the story remains the same in terms of the strategy. Like the strategy is pretty much to isolate x, right? Like that's our goal, isolate x. But sometimes we can't do that directly in the problems we're about to look at. So a good rule of thumb on the way to isolating x is to isolate a radical. See, because if you can isolate a radical, then you probably can get rid of the radical by squaring it or possibly cubing it, something like that. So let me get us started here on an example of this nature. So this would be like problem 45 in section 1.6. Here we go. What example am I on?
4.
4? Okay. What's that? Okay. So here we're up against x minus the square root of 2x plus 3, right? It's strange. The program that you're typing notes for in class, for some reason, is playing an advertisement. How odd. Let me go on. So, all right. So what can you not do? So I was talking about making a video full of wrong steps, right? So if I was going to do like wrong steps here, here's what I'd be like. So that's like, you know, square root of 2 times square root of 2x plus square root of 3, right? And then, yeah, like this is not allowed. You can't do that. There's no such property, all right? Square root does not do this. The only way to get rid of a square root, pretty much, is this. How do you get rid of a square root? square it. And that's 2x plus 3.
Oh, so
The plus minus only happens the other way around. The square root of 2x plus 3 squared, that's plus or minus 2x plus 3. But this is not that. These are different. The order matters. Okay, square or square root, you just get back what goes into the square root, right? Yes?
So then would you kind of combine like terms to make it easier?
We cannot combine like terms. There is no way to bring the x into the square root.
Can you add 2x the square root
No,
of
like
x
two,
plus 2?
like any plus.
Guys, you got to stop talking. I can't hear people talking who actually have questions about class. So, what were you asking me? I think Beth Ann, were you asking me? Never mind. All right. So, look. So the way to do this is we isolate the radical. Then square it. Yep. And so when we do that, what do we get? We get x squared is 2x plus 3.
Can we factor that?
Can we factor? So you got x squared minus 2x minus 3 equals 0, which is, what did you say, x minus?
X plus 2 times x plus 1. Or no, sorry, minus. Yeah, sorry, I have my...
X what? X minus what?
X minus
1.
x plus 1, x minus 3. Yes, that. Yeah, otherwise, look at all that. Minus 3.
But yes, it factors, right? Let's check. Plus 1 minus 3 gives me minus 2. All right. Wonderful. What are the solutions? All right. Wonderful. Now what? Do they work? See, here's the thing. This step right here, you may have added extraneous solutions. In the process, whenever we square the equation, we're erasing the sign of both sides. If it was minus, when we square it, that minus is gone, right? So we're losing information when we square, and in some sense we can be adding additional solutions. So if you go back and try this, what happens? Like, how about x equals minus 1? Does it work? Minus 1 minus the square root of 2 times minus 1 plus 3. How's that go? Minus 1 minus the square root of 1, right? Which is minus 2, which is not equal to 0. So this right here is extraneous. How about x equals to 3? Does that one work? I get 3 minus the square root of 2 times 3 plus 3, also known as 3 minus the square root of 9, which is 3 minus 3, which is 0. Hooray. So in fact, yes, x equals to 3 is the real McCoy. It's, actually a solution here. So
Wait, so if we put both?
if you put both, you would be wrong.
But if you left it at x equals negative 1 or x equals 3, you'd be wrong.
Yeah. You need to rule out the extraneous solution. Usually I say solve the problem, so I don't mean give me the answer and then other things which aren't answers. Because if I didn't make this the case, then everybody could always just write the real number system as the answer to everything, and then you'd have the right answer in there somewhere, and then infinitely many wrong answers, and I couldn't count it wrong if that was my custom. So yeah, I insist on us finding the answer. But you see why the minus 1 didn't work, right?
Yeah.
Now, minus 1 is the solution. Minus 1 is the solution to this problem. If you go minus x equals minus x, if you go back to minus x minus the square root of 2x plus 3 equals to 0, this problem has the extraneous solution as the solution. So this would have given you, like x is equal to minus the square root of 2x plus 3. And the thing is, if you take this problem and you square it, you get to the same quadratic. So that's the thing is, like, when we square both sides, we erase that minus. And so this problem and the given, so this is a different problem, right? But if you take this and you square it, we get to the same point. And that's where this minus 1 is coming from. It's the solution to a related but different problem. If you look at minus 1 going into here, you'll get minus a minus 1, which is 1. 1 minus 1 is 0. It works in this problem. But anyway, let's go on here. Let me look at one that's a little bit uglier. Here's number 53. Suppose we're looking at square root of x minus the square root of x minus 5 equals to 1. How do you deal with something like this? Square it. Now, okay, let's do that. If you square both sides, right? What happens? You get the square root of x times the square root of x minus 2 times the square root of x times the square root of x minus 5 plus the square root of minus x minus 5 times the square root of x minus 5. If I FOIL that out. Was that a good idea? So that's not what you want to do. Squaring immediately is not a good idea. Now some of you, please don't do this, would have said, oh, well, isn't basically your idea is if you have a minus b and you square it, you just get a squared minus b squared, right? That's the pattern you're thinking about in your head. That's why you told me to square it. You're thinking I can just square each separately and that's how it works. That's not how it works though, because a minus b squared is not equal to this. It's equal to a squared minus 2ab plus b squared actually. That's how that multiplies out, right? So we can't, I would advise against just squaring it. A better thing to do is to isolate a radical. So this is the game plan. Every time, isolate a radical. It doesn't matter which. We can isolate x. We can isolate square root of x minus 5. Which one do you guys want to do? Let's isolate square root of x. So square root of x is equal to, oh, I regret that. I'm going to do the other way around. So I have square root of x minus the square root of x minus, I'm just writing the problem down again, equal to 1. All right, that was the given problem. If I want to isolate the square root of x minus 5, what's that look like? It's the square root of x minus 1, right? Let me just pause for a second. Everybody with me? So the larger point here is when we're squaring both sides, we have to think about FOILing things out, all right? If there's a sum or there's a difference, we have to multiply it out. So when I square both sides, I get x minus 5 on the left-hand side, right? But on the right-hand side, I'll write it out. I've got this times this, right? And how does that multiply out? You have square root of x times the square root of x, right? Which is square root of x squared. And then you have 2 times the square root of x subtracted. And then you have plus 1. Now that's actually very nice, right? How does that simplify? X minus 5 equal to what? Square root of x squared is just what? X. So we've got x. And then minus 2 times the square root of x. Okay, great. Plus 1. Ooh, look at that. This doesn't always happen, but in this one, you see how that and that are the same? So we can cancel them, right? Subtract x from both sides. And my next move would be to isolate the radical. So I've got minus 6 is equal to minus 2 times the square root of x. I canceled the x's and I subtracted 1 to the other side. You guys with me still? Then so the game plan here at each step is to isolate the radical. So how can I isolate the radical now? Divide by negative 2. I like that. So that will give me 3 equals to the square root of x. And then how do I solve for x now?
Would x be plus or minus 9?
So I have the square root of x equals to 3, just write it the other way. And then I square both sides, right? The square root of x squared is x. And the other side is 9. So we just get, remember the plus or minus comes from when we're taking the square root of a square. That's not what we're doing here. So apparently the answer is 9. Is it though? Does it work? What happens when you try it out?
3.
Square root of 9 is 3. 3 minus what's 9 minus 5 is 4. Square root of 4 is 2. 3 minus 2, 1, right. Cool. Now check this out. If we did the same problem, almost the same problem with this one, if I had solved instead the square root of x minus the square root of x minus 5 equal to minus 1, I think that you can track through the steps that we made, right? I could be wrong. Well, let me not speculate. That's too much. It's too many steps to speculate. Let me not. What I'm trying to say is it's conceivable in this kind of problem that there could be no solution. It could happen. It could be that when we squared this equation, if when we squared this equation, we'd actually, introduced well, anyway, it's possible for I'm just trying to say it's possible for there not to be a solution. Maybe the next one I pick will be like that. All right, so you guys pick any number between 50 and 74.
71.
71 it is. All right, so the fourth root, oh, this one's too easy. But, you picked it. So example, this one won't take long. Here we have x minus 15. The fourth root of that equals to, I think, 2. Yeah, how do you solve that? Say what? Right here. What is the natural enemy of the fourth root function? What's that? Raise to the fourth power function, right? The power 4 function. So raised to the fourth power both sides. So this is basically you've got Pac-Man to the 1/4 power, and we just raised it to the 4th power. So what do you get? You get Pac-Man, right? Although my children accuse me of just writing a fortune cookie there, so I don't know. Oh no, I've ruined it forever. I love my children. Of course I do math with them. What are you talking about?
Like before bed every night. Instead of a bedtime story,
I have thought about anybody who wants to date my daughter must first solve a certain Lagrangian. But, complete the square. That's just like, that might, I don't know. What would that get? I don't know. I mean, I might let you in the house. I don't know. Okay, so then x is equal to? X is equal to 31, yeah. What's that? Yeah. Oh yeah, usually, maybe at some point this semester I'll bring in Benjamin to he's too sweet. You guys will corrupt him? Is that, what are you saying? I don't know.
Have you taught him how to complete the square yet?
No, Benjamin does not complete the square yet. I think Benjamin's mostly just doing like multiplication tables at the moment. He's 6. So let's see here. Pick another number between 50 and 74. I'll pick it for you. 63. Well, 52? 50. Oh, 50. What's that? 67. Oh, 67 might be good. Where was I?
about Benjamin.
You have one more question about Benjamin? All right, go ahead.
At what age, if he still can't complete the square, does he go to the orphanage?
Don't be silly. If my children can't complete the square, I don't send them to the orphanage. I just make them sleep outside. I'm just kidding. I'm just kidding. They would just not be allowed to have supper. What am I saying? Let's see here. No, I'm still kidding. They would just not have game time. Let's see, probably. Let's see here. Something. At what age, though? Oh, I don't know. No age. No age. Let's see here. We don't call them orphanages anymore. We call them children's homes, you know. Where you been? Because sadly, children's homes are full of children who have parents who are alive, who are just not behaving. All right, so how do you solve this?
You just eliminate the cube roots.
And how would you eliminate the cube roots?
You just write it without them.
Just write it without. Operationally, you can take both sides, cube both sides, and then
That's like what I said.
that is what you said.
Does that?
Minus 2x.
So what do you? So you guys get what do we find? 2x equals to minus 4. X equals minus 2. Very good. Yep.
Why can we cube this one when we couldn't square the other one? Is it because they were
So the reason that we couldn't just why couldn't we just square the other one? The reason is that we had a difference of the square roots. Let's work another one like that. So if we have, for example, let's see here. Let's see, we could do, I'll do 63. The square root of 2 times the square root. Oh, this isn't what I wanted to show. Let me not do this. I mean, I'm intrigued by 63. 63 looks fun, but it's probably not achieving the purpose I want at the moment. So here's another one. Square root of square root of 2x minus 5 equals to 2 plus the square root of x minus 2. Now, unlike example 5, I don't really need to do any kind of pre-processing here. Like there is already a radical that's isolated, right? So squaring both sides is a good idea, actually. However, we must do it correctly. And what do I mean by that? I mean, we actually have to think through the process of squaring that. So this is 2x minus 5 on the left-hand side is 2 minus the square root of x minus 2 times 2 minus the square root of x minus 2. That's what it means to square it, right? You multiply it by itself. And then we have to FOIL that out, right? There are terms to think about. 2 times 2, 4. And then we have minus 4 times the square root of x minus 2. Those are the cross terms, right? Like this times this, that times that. Both give you 2 times the radical with a minus, you know? So I get minus 4 times the square root of x minus 2 from the middle terms. And then what?
Why are you doing 2 minus the square root of x minus 2 instead of 2 plus?
Aw, man. That's a good question. I can fix it. I can fix it. There we go. Thank you, thank you. I do appreciate the correction. And so what happens? You've got 4 plus 4 times the radical x minus 2. And then that's x minus 2 again, yeah? All right, so now what do we want? Now what do we want to do? We want to isolate the radical again. So I would have 4 times the square root of x minus 2 is equal to, let's see here, 2x minus 5 minus this 4 minus that x plus that 2. Can you clean that up? I think we can clean that up. That's just what, x? I've got what, minus 9 plus 2 minus 7.
Aren't you adding 5 before?
It's on the other side.
Oh, okay. Oh,
So
you
I'm just,
and
yeah, this is these. So then, you got choices here, guys. Once you get, so here's, I say isolate the radical, but you know, when a problem like this, if you don't want to work with fractions, sometimes it's a smart move to just leave the 4 where it is and square both sides. Because if you don't do that, you're going to have to work with fractions, and we don't like fractions, so let's just square both sides. All right? Squaring both sides does what? 4 squared is what? So I get 16 times x minus 2, and then I square this out, right? Which gives me x squared minus 14x plus 49. What's going to happen next?
16 times x minus 3.
Yeah, 16x minus 32 is x squared minus 14x plus 49.
Isn't that the x squared minus 14x plus 49
Yeah,
squared?
x minus 7.
Yeah.
So we have x squared minus 28x. And then what happens when we take 49 plus 32? What do we get?
49 plus 32, 8. What did he say?
Plus 81? Is that right?
Wait.
79 plus 1, 81, yeah.
Isn't negative 14 minus 16 30?
Oh, thank you. I was about to say, this doesn't look quite right. So that was supposed to be minus 30? Thank you. Hey, that's way better. Why is that way better? Can you factor that? What's 81? 81 is 3 times 27. So we want a minus 30. So we do x minus 3, x minus 27. That factor, so it factored nicely. This is, after all, a book problem. That tends to happen. So x is equal to what? And do you think they both work? I doubt it. If I plug in 3, I get square root of what? 6 minus, so I get 1. The 3 does not work. I can tell from plugging it in. I think the 20. This is extraneous. If you plug it in, that's extraneous. That's the answer. Anyway, thanks, guys.